Hello, see you guys again. I'm Tom. And today tutorial we are talking about binomial expansion. How to expand a plus a to the square or a plus x to any integer's power. For example, 40. This is called the binomial expansion. You also learn Pascal triangles. In this triangle, you can see all the ones going down from the outside of the triangles. And then in the inside of the triangle, we have 1 plus 1 is 2, and 1 plus 2 is 3, 2 plus 1 is 3. We form row 0 to row 4, and also row 5, and so on. And for the factorials, if we have any integer number n belong to some integer number, n factorials we denote by n to the exclamation marks is equal to n multiplied by n minus 1 multiplied by n minus 2 until 3, 2, and 1. This is called the n factorials. For example, 1 factorial is 1, 2 factorial is 2, and so on up to 7 factorial is 5040. And by convention, 0 factorial is equal to 1. Okay, let's jump to the lesson. And we will learn these three topics one by one. Let's go. Binomial expansion. Pascal triangle. The expansions of a plus x to the power of 2. We can use this multiplication. A plus x to the power of 2 is equal to a plus x multiplied by a plus x. And then we multiply each term into each other. We have a squared plus ax. For the second multiplication, we have plus ax plus x squared. So we have a squared plus 2ax plus x squared. And how about a plus x to the power of 3 is equal to a plus x multiplied by a plus x to the power of 2. So it's equal to a plus x. And this term we have got it from the upper equation 1. So we have multiplied by a squared plus 2ax plus x squared. Multiply each term to each other. We have a3 plus 2a squared x plus ax squared. And for the second term multiplication, we have a squared x plus 2ax squared plus x squared. So we got a to the power of 3. For the equal term of x, we have this. So plus 3a squared x. For the term of x squared, we have plus 3ax to the power of 2 and plus x squared. So we have another binomial expansions of a plus x to the power of 3. And this is what we get. For the a plus x to the power of 4, we have a plus x multiplied by a squared plus 3a squared x plus 3a x squared plus x to the power of 3. Multiply each term together, we get a to the power of 4 plus a plus 3a to the power of 3x plus 3a squared x squared plus a x squared, and then the second term multiplication plus a3x plus 3a squared x squared plus 3a x squared plus x to the power of 4. So we have a to the power of 4. For the terms of x, we have 3a squared and 1a squared. So we got 4a squared x. For the term x squared, we have 3a squared and 3a squared. So we have 6a squared x squared. For the term of x squared, we have 1a and 3a here. So we have 4a x squared. And for the term of x power 4, so we got to the power 4. We got another binomial expansion like this. Now in general, we see that's the coefficient of a plus x to the power of n, which n is any number, come from the nth term rows of a Pascal triangle, in which each term is the sum of the two terms just above it. Let's see what we mean by this. This is the Pascal triangle. We have the one come all the way down here from the outside of the triangle. A plus x to the power of 0 is the row 0. And for row 0, we got a plus x to the power of 0. So it's equal to 1. Get the coefficient of 1 here. And for the row 1, we have a plus x to the power of 1. So we look at the coefficient only. The coefficient of a is 1, coefficient of x is 1. So we have x1 and 1. And for the row 2, we have a plus x to the power of 2. We have a squared plus 2ax plus x squared. If we look at the coefficient only, 1 here, 2 here, and 1 here. So here, 1, 2, and 1 is only the coefficient. And for the row 3, we have a plus x to the power of 3. The expansion above, we have a cube plus 3a squared x plus 3a x squared plus x to the power cube. Just look at the coefficient. We have 1, 3, 3, and 1. So it's 1, 3, 3, and 1. And this form the what's so-called is the Pascal triangle. And the Pascal triangle, we can get it easily from the triangle here, because 1 plus 1 is 2. We got 2 here. So 2 plus 1 is 3. We got 3 here. 2 plus 1 is 3. We got 3 here. And then the next row 4, we can get it from 1 plus 3 is 4. 3 plus 3 is 6. And 3 plus 1 is 4. And for the outside of the triangle is always be 1. So what we got here is called a Pascal triangle. And you can calculate the row 5 as well. Do an exercise for the row 5. Outside of the triangle is always be 1. And 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10, and 4 plus 1 is 5. So we can know that's the coefficient of the expression a plus x to the power of 5 is equal to 1, 5, 10, 10, 5, and 1. So what this means is that if we have a plus x to the power of 5, we can write a to the power of 5 plus 5, a to the power of 4, x plus 10, a to the power of 3, x squared plus 10, a to the power of 2 x cubed plus 5 a to the power of 1 x to the power of 4 and plus 1 x to the power of 5. So from the Pascal triangle, we can easily get all the coefficients of the terms of x to the power of 0 right down to the terms of x to the power of 5. Now we try to do the following exercise. If we want to find 2x minus y to the power of 4 and expand it into this term, get this solution. So we let a is equal to 2x, and then this one is minus y. So x is equal to minus y. We have a plus x to the power of 4. And from the Pascal triangles, we get all the coefficients. The coefficient of a to the power of 4 is 1, and plus a to the power of 3, x plus a to the power of 2, x squared, plus a to the power of 1, x cubed, x to the power of 4, where the coefficient of the Pascal triangle is 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. This is the coefficient of the level of 4. So we have here, this is 1, and this is 4, 6, 4, and 1. And then we substitute a is equal to 2x into this expansion. We have 2x to the power of 4 plus 4 times 2x to the power of 3. X is minus y, and then we have plus 6 2x to the power of 2 minus y to the power of 2, and then plus 4 2x to the power of 1 minus y to the power of 3. Finally, we plus minus y to the power of 4. 2 to the power of 4 is 16. X plus 2 to the power of 3 is 8. And times 4 is 32. X cubed, this will be x to the power of 4. And then minus y to the power of 1 should be minus. So we change this back to minus here. And then we x 2 to the power of 2 is 4. 4 times 6 is 24. X squared, one should be y. And then minus y to the power of 2 is y to the power of 2. And then plus 2 to the power of 1 is 2 times 4 is 8. And this one is x minus y to the power of 3. We got y to the power of 3. And then we got a minus here. So we change it back to minus. And then we have minus y to the power of 4. So we got plus y to the power of 4. Okay, so we got all of this term from here. Get the solution. Equal to this solution, 16x to the power of 4 minus 42 x cubed y plus 24 x squared y squared minus 8x y to the power of 3, and then plus y to the power of 4. After this exercise, we come up to another topic. It's called factorial. So what is factorial? To understand the coefficient in Pascal triangle, we need the factorial function. It's n to the factorial. We denote it n and then exclamation marks. N factorial is equal to n multiplied by n minus 1, n minus 2, n minus 3, and it's also going down into 3, 2, and 1. Of course, n is any integer number, so n is belong to the integer number. And also we have 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, 4 factorial is 4 times 3 times 2 times 1 is 24, and so on. So 7 factorials is 5040. By convention, 0 factorial is equal to 1. We do another exercise. The question is given 4 objects saying the letter A, B, C, and D. How many different order can you put them in? For example, some possible order is A, B, C, D, D, C, B, A, B, D, C, and etc. The first letter can be of any number from the 4 character. Let's say it's C. And the second number is from any remaining 3 number is A, B, and D. We choose A. And the first letters can either of the remaining 2 letters D or B. We choose D. Finally, the remaining character should be B. So we have C, A, D, B in this case. So how many cases we can reorder the 4 letter A, B, C, D? Let's try it by hand. We have A, B, C, D. Keep the first character the same. So another possibility is A, B, D, C. Okay, another probability is that A, C, B, D and A, C, D, B. Finally, it's A, D, B, C, A, D, C, and B. And how about we keep the first character is B? So we have B, so A, C, D, and B, A, D, C. And then B, C, A, D, B, C, D, A, and then B, D, A, C. For B in the first position, finally we have B, D, C, A. How about C in the positive position? We also get 1, 2, 3, 4, 5, 6. D in the first position, 1, 2, 3, 4, 5, 6. So we have 6 times 4. We have 24 possible ways to reorder this character. This is the way we do it the hard way. We lay out all the possible ways, and now we use the factorials to do the following exercise. So if we have 4 characters, that means the factorial of 4 is the way we reorder these characters. So 4 factorial is equal to 4 times 3 times 2 times 1. 4 times 3 is 12, 12 times 2 is 24, 24 times 1 is 24. So it's 24 possible order to order these characters. And the n different objects, there are n factorial possible order, or what we call is the permutation. Another example is about factorial is how many ways are there of arranging the letter Pascals. So in here we have P-A-S-C-A-L. We have 6 characters here. Does this mean we have 6 factorial ways to reorder these characters? No, it's not, because in this words we have 2A here. The answer should be 360 ways. How we calculate 360 ways? We do it this way. We have 6 characters, so we have 6 to the factorial way, but 2 characters is the same, so we have to divide by this 2 factorial. And then we use the expansion 6 times 5 times 4 times 3 times 2 times 1 is the 6th factorial. And 2 factorial is 2 times 1. So we cancel out this 2 and this 1. We got 6 times 5 times 4 times 3. 6 times 5 is 30. 4 times 3 is 12, right? So 30 times 12 is 360 possible ways to reorder the letters of Pascals. So now we understand what is factorials and when we use factorial to solve the question of this 4-character rearrangement or this word Pascal rearrangement. And the arrangement of the letters or some group of items, we call this permutation.